I'm coming to you from Arizona, and I'm going to drop back or take a 30,000-foot view of the space race and what's going on in space. Vitaly gave you some, really important and excellent information about space debris. I will talk about it very briefly in a basket of other issues that are going on in space. So this is sort of your big picture, if you like. And it's very relevant to what the United Nations is gathering for, because there are a set of issues here that really need the attention of the global community. So I'll summarize some of the issues. They're all familiar to you. We have some very ambitious and deep-pocketed people that are doing the private space industry, and it's moving very rapidly indeed. There's a sense from a lot of people in polls that this is a distraction. Most people, when they're surveyed, think we have plenty of problems on the Earth, so why are we even bothering with space? Why are we messing around up there? It's also always been true that space is not a place built for us. It's an extremely unpleasant, brutal, and challenging environment. So it's not a very natural place for us to be, you might argue. And some planetary scientists and astronomers have long argued that whatever you can do with people up there, you can do far better, cheaper, and more reliably and safer with robots. So why are we not just using our very clever, increasingly powerful robots attached to AI, if you like? We know that the space debris problem is bad and it's getting worse. And then there's a sociological issue that is of concern to many people, that as we play out in what is essentially a new Wild West, the space arena, all these various experiments, we may see the worst sins of colonialism revisited in a new large arena. It's important to just take a moment to realize this is a young thing that humans have done. We've had in science for a few hundred years, the Industrial Revolution. We've had space travel for a very short time, just a couple of generations. Only 650 people have ever been in orbit. There's 10 times more that have stood on the top of Mount Everest. So this is an activity in its early phase, and it had a very strange history because it was dominated by a geopolitical contest between the world's two superpowers for most of the history. And it's only just now changing its complexion. And the complexion is changing because of the private sector. And I'll just pick out three of the most obvious people because they have very high profile billionaires leading their efforts. Richard Branson, who poached Burt Rutan, probably the best aircraft and spaceship designer of the 20th century, to form his spaceship company. They've had a big problem and an accident and fatalities, but they have 50,000 expressions of interest to do a sort of suborbital joyride. Blue Origin, founded by Jeff Bezos, he keeps it afloat still by selling $1 billion in stock every year. And he sent 14 tourists to space in 2021. That's a record. SpaceX is more familiar. Jeff Bezos is a little quiet, avoids publicity. Elon Musk is obviously a publicity hound and likes the limelight. And for all the bluster, and there's plenty of bluster, we should remember that he's had over 260 launches of the Falcon 9 rocket, I think with only 2 failures. That's an incredible success rate. And he's floated his business, apart from his own personal fortune, by partnerships with NASA to resupply the space station and send astronauts into orbit. So that's how these companies are sustaining their early phases when they don't really have a revenue stream. And I'll remind you, these new rockets are very big. Here's Elon Musk's new rocket that will get us to the moon and Mars, and NASA's partnering with him on that. And it exceeds the Saturn V for the first time in 60 years. And its launch cost per kilo is hundreds of times lower than the launch cost of the non-reusable Saturn V. So this is a total game changer in the space program. And that's the basis for the excitement you're seeing now in the commercial sector. The economics are interesting because, again, it's being driven by very rich private individuals for the most part, but there are about 30 private or commercial space companies, some flying under the radar but doing very interesting things. Here's the growth in the world's billionaires, and we see that these space entrepreneurs have spent a substantial amount of their money. Now, these people, a handful of them, can exceed NASA's entire budget easily. So we see there's a lot of economic clout. The world's trillionaires are collectively worth about $12 trillion. And it's maybe not a coincidence that the two richest people on the planet in Forbes' list are leading the two most prominent private space companies. I used some data that's available on the average cost of a space mission and the average cost of movies. So I did a little internet research, and you'll be interested to see that in the history of the space program, the average price of a space probe is now cheaper than the average price or cost of a movie. I'm showing some outliers here, very high and very low priced space missions and very high and low priced movies, maybe some of your favorites. And when I'm talking to audiences about the importance of space science and astronomy, I make the point that if you had $400 million burning a hole in your pocket, you could get a very good director, James Cameron, to make a beautiful movie about life on an exomoon, Avatar. Or with that exact same amount of money, you could build a 1-meter telescope, the Kepler spacecraft, and actually find hundreds of Earth-like planets. That's what the science costs. So to me, that means the science is a pretty good deal. We can do both, of course. And pursuing this analogy, or a different analogy a little bit, I'll compare what's happening in space to the evolution of the internet. Maybe this analogy is a little bit of a stretch, but you'll see where I'm going with this. The internet essentially has had 4 phases. There's the pioneering phase. The person on the bottom left, I doubt most people would recognize. That's J.R. Licklider. He was a consultant for the RAND Corporation, and in 1960 released an extraordinary white paper that, remember, in a time when an average mainframe computer was the size of a family home, he visualized the wireless internet, a handheld device that was a powerful computer, satellites delivering data around the world. He visualized all of that in 1960. Extraordinary. The activity was incubated by the military industrial complex, if you like, and that's because it costs a lot of money to develop email and the internet. And so the first people who had email worked for government research facilities and military contractors. And then eventually it moved into the university world. And then it was also into the research arena. And here we have this afternoon's speaker, Vint Cerf, who, despite what Al Gore said, Vint actually did invent the internet. He developed the TCP/IP protocols. That is how packet switching works. It's how the internet architecture is designed. And we have also work done out of major research facilities. The web browser developed out of the nuclear physics lab at CERN. And so we have a very vital research going on in institutes and universities. And in 1995, something extraordinary happens. We call it the Big Bang of the internet. In 1995, an obscure company with a strange name, Amazon, decided it wanted to do more than just sell books online. 2 young graduate students at Stanford figured out search, and the first internet service providers were put into existence, all of which are out of business now. I doubt you could look back with hindsight now to 1995 and predict what the internet would be, a $4 or $5 trillion part of the world economy. So that's the commercial world we live in now, the internet. And if I use this analogy, we have a pioneering phase in the space program. There's J.R. Goddard with his first liquid-powered rocket. It's just a cousin of the modern rockets. They haven't really changed. We're still using chemical energy, which is very inefficient. And this little single-stage rocket at the top of that stand traveled 150 meters across his Aunt Effie's frozen cabbage patch in the Midwest. And who could visualize from that to the Apollo and the moon landings? Then the incubation, again, by the military-industrial complex, the slightly unsavory part where Wernher von Braun was spirited back, surrendering to the Americans rather than the Russians at the end of the Second War. He had blood on his hands from the Middleworks rocket factory where 8,000 or 9,000 slave workers died. And then in my homeland of the UK, another similar number died from the V-2 rockets. His Nazi connections were sanitized and scrubbed, and he, of course, became the architect of the Saturn V and an essential NASA employee as they developed the space program. Into the research arena with the space station and the space shuttle, a lot of research done. And so now I am positing that we are about to go through that transition, the analog of 1995 for the internet, when the commercial sector takes over. And I also believe that with that same difficulty of hindsight in 20 or 25 years, we'll have trouble looking back to predict where we might have got to. There are issues that need to be dealt with. Space is a wild west. I live in Arizona, so I'm going to tell you directly, it's a wild west out there. There have only been two international space treaties with UN signatories. The Outer Space Treaty was essential because it banned weapons in space and was signed by all the major powers in the world. The Moon Treaty of 1979 covers rights in space and who owns what, and was not been signed by any of the major spacefaring powers still. And it's also mute to other than countries. It doesn't say anything about commercial activity or private ownership. So it really is lawless up there in terms of who owns what, who's liable for what, how law projects into this new large arena. Since then, of course, there has been continuing activity in the UN through the Committee on the Peaceful Uses for Outer Space, and there early on were three very useful additional agreements, not at the level of treaties, to oversee the rescue of astronauts if they're stranded, so people would cooperate on that, to deal with some of the liability issues, and just to register objects that are in space and make sure everyone knows what's up there. COPUOS meets every June, and 66th meeting was just a few months ago, has 112 members, is one of the largest bodies in the UN. Now, recently, it has approved 21 non-binding sustainability guidelines, but they are completely voluntary. They're non-binding. The more interesting thing that's happening is it currently has a working group, which has a purview and a timeline of 4 years to develop potentially new treaties. So for the first time in half a century, there's the possibility that the UN could develop some treaties to deal with some of these intensely important legal and ethical issues, and the issue of space debris, of course, among them. It's been very slow and halting progress, and many of the people involved, and I know some of them, are not that optimistic that a new treaty will emerge from this work. The space debris problem is getting worse. As we know, Elon Musk has enormous ambitions. We're projecting probably to 100,000, mostly small satellites in Earth orbit by the end of this decade. It's a dramatic rise. They're doing something that in principle is good. Many of them are delivering high-speed internet to every location on Earth through developing countries that haven't had it. But they are also creating junk debris, and there's no oversight of this activity. And it's often said that space debris is a tragedy of the commons, where we all benefit from something and exploiting it, but we can't stop others from doing it, and nobody takes charge of this. There's a scenario that was outlined by a NASA scientist in 1979, the Kessler scenario, where the cascading collisions lead to such a large amount of small pieces of debris, and Vitaly gave some numbers, and I put some more here on this slide, where low Earth orbit becomes unusable. And that's a dire scenario. I'm not sure it's just around the corner, but the problem is that mitigation strategies are not very efficient. Even low Earth orbit is a big volume and region of space. And there are harpoons and space nets and magnetic devices, all sorts of clever strategies. The Europeans and Americans are prototyping them. But it's really a tough sledding to get that debris under control, and we're just adding to it as we speak. There's an environmental issue. What are we going to do in space when we start to colonize the moon and Mars, when we mine asteroids, when we have a large industrial and commercial activity off Earth? Will it be the American version of national parks, where we have a pristine preservation of these special spaces and we keep them as they were? Or it will be an ugly version of Manifest Destiny as it's played out, where the colonial powers essentially treated large parts of the world as their resource, including the people who live there. Where are we in this chronology? Well, the future is right here. It's not around the corner, it's right here. There's the history of space launches since Sputnik, and on the top you can see the world's superpowers, the United States and the Soviet Union, and then much more recently, but in a resurgent way, China. China had 70% of the total launches of the US last year, so it's coming up fast as the world's leading superpower. They have ambitions, of course. They're going to have their own space station. They have plans for a moon base, a Mars base, all the things that Europe and the Americans are thinking of, they are planning. Their space program grows at the rate of their economy, which until recently would be a doubling every 4 or 5 years. NASA's budget is stagnant, actually declining in real terms. So the Chinese are doing amazing things. And you can see the commercial providers on the bottom growing. in global terms, the last 2 years have each seen more launches to low Earth orbit than any year since Sputnik. So this is really an exploding activity, well, luckily, not literally, but metaphorically. So the future is here, and we really have to plan for the future. What's driving this is the reusability of the rockets. And here's the cost per kilo to deliver to low Earth orbit. And if you look at the last decade, or the 2010 to 2020, you'll see that the cost per kilo has dropped by an order of magnitude in 10 years. That's a dramatic gain. And that's entirely because of the efficient designs and reusability of the SpaceX and Blue Origin spacecraft. And then we can project further gains. And if we continue this curve, then eventually getting into space is essentially going to be free. That would happen with something that can't actually be built now, but is worth talking about now, which is a space elevator. This is an essential piece of infrastructure for the future of living and working off Earth. We cannot build a space elevator. It's like an Indian rope trick. It's a cable strung high above geostationary altitude such that it's sustained, the weight of the object, the elevator, the cable, is sustained by centrifugal force. This is not possible to build on the Earth, but it is, with current materials, with nanotube technology, possible to build it on the moon with 1/6 gravity of the Earth. So the prototype of a space elevator will probably first be built on the moon to go along with the moon base. On the Earth, we don't have the materials that could build an elevator with our much stronger gravity, but I think they're coming. It's a fairly safe assumption that the engineering of this will be possible. And the price tag, estimated anywhere from $5 to $15 billion, is completely tractable. Any set of corporations will get together. Because when you have a space elevator, you remove the entire cost of launch, of the rocket fuel, of going against the Earth's gravity. Use solar-powered lifters to go up and down the elevator. Takes quite a while. And then you're in Earth orbit. You're free. Half of the energy cost of going to Mars, for example, is in going the first 400 miles to get into low Earth orbit. So this is a game changer if we develop it. And also on the horizon, and not that far, maybe a few decades, is the prospect of mining asteroids. We know that economic progress in the Earth has been fueled by access to cheap metals and minerals. And currently, technological development is being limited by access to those cheap metals and minerals, because strategically, they're sometimes not in the hands that we want them to be in. There are 500-meter near-Earth asteroids on judiciously selected orbits, which we could capture into a captive Earth-Moon orbit and then mine at leisure. And rough estimates of the value of the platinum group metals on such an asteroid are about $2 trillion and another $2 trillion for the rare earths, which, as we know, are essential for all our modern electronics, batteries for electric vehicles, and so on. Also, these asteroids have water, which is an incredibly rare and important commodity for doing activity in space. And it's, of course, extremely expensive if you have to launch it off the Earth. So the asteroid prospect of mining asteroids, I think, is also going to happen. And we will eventually get a base on Mars. And when we start to live off Earth, we're going to face another set of issues. Maybe they seem a little remote to most of us, but they have to be taken seriously. The people who colonize the moon and Mars, especially if they're not funded by governments, but by private individuals, will have free reign to be rather aggressive modifiers of their own genomes. They will push the envelope of modern medicine with nanobots. They'll modify their own genes. They'll hack their own genes and their genomes, which they're entitled to do. And they will push techniques of 3D printing allied to medicine. Some of this is exciting. Some of it's a little scary. Cloning and so on. There are all sorts of possibilities. And again, there's no regulatory framework to prohibit some of these things happening. So that's what we're looking at. And again, these are timeframes of 10 to maybe 30 years. So to finish, let me summarize the prospects. And they're not all dark at all. Some of them are good. A recreation for the masses, okay, it becomes cheaper to go into space. It's very close to being the cost of an expensive cruise soon, within a couple of years, and then it'll get very cheap. But it's not something most people are ever going to do, or maybe ever afford to do. Why live off Earth when it's so difficult, when it's so ridiculously hard and a hostile environment? A small argument for these technologies is that to learn how to live in an off-Earth environment, you have to use technology to be extremely parsimonious, to live off the land, if you like, to make your own food, your own water, your own building materials, which we will do from the moon soil and the Mars soil. And we will harvest water from that soil. We will separate the water into oxygen to breathe, and then make rocket fuel out of the hydrogen too. So there are technologies that are actually illustrative for how we might live on Earth more parsimoniously. And maybe eventually, in a grandiose way, we'll actually start to master the solar system. The space elevator may seem frivolous, but think, when you have a way to get stuff very cheaply, almost for free, into Earth orbit, we can solve a problem that's vexed us for decades, which is cleaning up toxic and radioactive waste. We bury it underground. Rich countries ship it to poor countries. It's pretty unseemly. But we could actually launch it into Earth orbit and then deep space and solve a rather persistent problem of the nuclear age. For sociologists, it's going to be interesting to watch your favorite science fiction playing out, your utopian and dystopian socio-political experiments. Well, they're not going to be science fiction. They're actually going to happen in the next few decades. And the last thing I'll say is that there's an opportunity here. There's an opportunity for policymakers, for ethicists, for legal scholars, and a whole new field of law, which is already growing around us, to take this clean slate of our future in space and figure out how to work with it and do something positive and productive with it. And to remind you, I think this is not the end of anything. This is just the end of the beginning. Thank you.